Hello everyone, how was your day? Welcome back to Artificial and Facts channel. In this video we are back with another topic. But before we move on to the video, don't forget to like and subscribe to this channel. Thank you. And now without further ado, let us move on to the video. Prediction of interval estimation. What is interval estimation? Let us take a look. In statistics, interval estimation is the use of sample data to estimate an interval of plausible values of a parameter of interest. This is in contrast to point estimation, which gives a single value. Intervals are statistical estimation approaches that employ survey data to generate value ranges that are likely to contain the population value of interest. Point estimates, on the other hand, are single-value estimates of a population value. Confidence intervals are the most well-known of the various forms of statistical intervals. Certain types of analyses and scenarios, on the other hand, necessitate the use of various ranges that provide different details. And now, we will learn different interval estimation methods. We will learn prediction interval formula and many more along with examples. Interval estimation in statistics is the computation of an interval, or set of values, within which a parameter. For example, the mean average of a population is most likely to be placed. The confidence coefficient is calculated by choosing intervals such that the parameter falls within them with a 95 or 99% probability. As a result, the intervals are referred to as confidence interval estimates. Upper and lower confidence limits are the endpoints of such an interval. In comparison to point estimation, which is a single number, interval estimation uses sample data to measure an interval of possible or probable values for an unknown population parameter. In certain ways, a point estimate is the best estimate of the parameter based on a sample. Any point calculation, it should go without saying, isn't 100% correct. It's just a guess based on a single random sample. Any point calculation, it should go without saying, isn't 100% correct. It's just a guess based on a single random sample. The point estimate would be expected to differ from sample to sample if repeated random samples were taken from the population. And now we will see the interval estimate formula. And this is the formula of interval estimate, where the z equals the confidence coefficient equals confidence level equals standard deviation equals sample size. Prediction interval. Provided particular values of the independent variables, a prediction interval is a range that most likely includes the value of the dependent variable for a single new observation. We're estimating ranges for individual observations rather than the mean value for this sort of interval. 95 prediction interval. There is a 95% chance that a future observation will fall within the prediction interval if we collect a sample of observations and measure a 95% prediction interval based on that sample. On the other hand, there is a 5% chance that the next observation will not be contained within the interval. If we take 20 samples and determine a prediction interval for each, we can expect 19 of the intervals to contain a single future observation, while one of the intervals will not. The most popular use of prediction intervals is in regression statistics, but they can also be used for normally distributed results. Point estimate of the population mean. The most fundamental point and interval estimation process involves the estimation of a population mean. Assume you want to calculate the population mean for a quantitative variable. The sample mean x, where the value of x provides a point estimate of, can be computed using data from a simple random sample. And now we will see what is the formula in finding point estimates. First, method of moments. It begins with known facts about a population which are then applied to a sample of the population. The first step is to create equations that connect population moments to unknown parameters, The next step is to select a population sample from which to estimate population moment. And second, maximum likelihood estimator. The maximum likelihood estimator is a point estimation tool that tries to find unknown parameters that increase the likelihood function. It compares data sets and finds the best fit for the data by using the values from a proven model. For example, a study may be curious about the average weight of premature babies. Because measuring all premature babies in the population will be impractical, the researcher will take a sample from a single area. The researcher will use the maximum likelihood estimator to find the average weight of the entire population of preterm babies based on the sample data, since the weight of preterm babies follows a normal distribution. And now I will show you how to find confidence interval using SPSS. But before that, let me explain to you briefly what is SPSS. SPSS stands for Statistical Package for the Social Sciences. SPSS is a statistical software suite developed by IBM for data management, advanced analytics, multivariate analysis, business intelligence, criminal investigation, long produced by SPSS Inc. It was acquired by IBM in 2009. Current versions have the brand name IBM SPSS Statistics. The SPSS software package was created for the management and statistical analysis of social science data. And now let us move on to the problem. A company manager wants to estimate the average time it takes a machine operator to complete a job. For that, 12 people were chosen at random. And now we will find an estimator for the 95% confidence interval using SPSS. Let us take a look. First of all, make sure your device has the SPSS software installed. Then we open the software and first we name the variable. We can write it as time. Then we take the data directly from Excel to input in the SPSS. And paste it directly in the time column. Then click Analyze at the top middle. Then click Compare Means. Then click One Sample t-test. And here conclude that we believe in 95% confidence level mean of population is in the range of 4.3 to 5.76. And that is how to find the estimate interval using SPSS. Look at this figure. This figure shows how a confidence interval generally looks like. And next we will talk about constructing a confidence interval. Step 1. Identify the sample problem. Choose the statistic like sample mean, etc. that you will use to estimate population parameter. Step 2. Select a confidence level. Usually, it is 90%, 95%, or 99%. Step 3. Find the margin of error. Usually given if not given, use the following formula. Margin of error equals critical value standard deviation. Step 4. Specify the confidence interval. The uncertainty is denoted by the confidence level, and the range of the confidence interval is defined by EQ1. And now, calculating a confidence interval. Calculation of CI requires two statistical parameters. Mean arithmetic mean is the average of numbers. It is defined as the sum of n numbers divided by the count of numbers till n. Standard deviation, it is the measure of how spread out the numbers are. It is defined as the summation of squared of the difference between each number and the mean. Using t-distribution, we use t-distribution when the sample size n30. Consider the following example. A random sample of 10 UFC fighters was taken and their weights were measured. The mean weight was found to be 240 kilograms. Construct a 95% confidence interval estimate for the mean weight. The sample standard deviation was 25 kilograms. Find a confidence interval for a sample for the true mean weight of all UFC fighters. The formula is shown in the video, where equals meant equals chosen t-value from the table above equals the standard deviation equals number of observations. B. Using a z-distribution. Use z-distribution when the sample size n30. Z-test is more useful when the standard deviation is known. Consider the following example. A random sample of 50 adult females was taken and their RBC count is measured. The sample mean is 4.63 and the standard deviation of RBC count is 0.54. Construct a 95% confidence interval estimate for the true mean RBC count in adult females. And you can see the formula in the video, where equals meant equals chosen t-value from the table above equals the standard deviation equals number of observations. Step 1. Find the mean. EQ2 if not already given. Step 2. Find the standard deviation. EQ3 if not already given. Step 3. Determine the z-value for the specified confidence interval. Putting the values in EQ7, we get this. Where lower limit equals 4.480, upper limit equals 4.78. Therefore, we are 95% confident that the true mean RBC count of adult females is between 4.48 and 4.78. Confidence interval is one of the foundational concepts of statistics. It tells a statement about the data. Various sampling methods such as mean, median, etc. can be used based on the data present. One can also determine what distribution to use when in order to get the best results. And that's all for this video. I hope you can learn something for this and see you in another video. Have a nice day.